Hello, grade 8 math class. Welcome to 5.2, comparing rational numbers. In this lesson, we're going to be comparing rational numbers or fractions in 3 different ways. The first way, we are going to take 2 fractions and turn them into equivalent fractions so that the denominators are the same. And then we will compare those fractions. The second way that we're going to compare fractions is using cross multiplication. And the third one is by putting numbers on a number line. So these are the 3 ways that we are going to be comparing rational numbers today. Just a reminder of what a rational number is. A rational number is any number that can be written in the form of A over B, where A and B are integers and B is not equal to 0. If you need a refresher, you can take a look at 5.1. It talks all about that. So for example, I can take the number 3, that is an integer. I can take the number -1/3, that is an integer. I can take the number 4.25. Sorry, these are all rational numbers. I'm calling them integers, but what I mean to say is that they're rational numbers. If I were to have a number such as 4 over 0, this is not a rational number because you can see that at the bottom we have 0, and over here it says B, so the denominator cannot equal to 0. So not a rational number over here. The next thing that's essential to talk about in order to compare fractions, comparing rational numbers, is to talk about equivalent fractions. What is an equivalent fraction? Well, I just took this definition from the book. It's on page 186 if you're interested in following along, and it talks about equivalent fractions. And equivalent fractions just represent the same number. So they're reducible to the same fraction. So I just drew this picture here, a very crude picture here, where I drew 1/2, and right underneath that I did two quarters, and underneath that we have 3/6. So you can see I've shaded in 1/2 of this block here. I've shaded in 2 quarters of this block here and 3/6 here. And I can say that 1/2 and 2 quarters and 3/6 are the same. So say I was eating a chocolate bar. This is a chocolate bar. If I have half a chocolate bar, I'm happy. If I have 2 out of 4 pieces of a chocolate bar, the same chocolate bar, I'd still be happy because it'd be the same amount. Or if I took that chocolate bar and I chopped it up into 6 pieces and had 3 of them, I'd be happy because it'd be the same amount and my buddy could have the other half. These fractions 1/2, 2 quarters, and 3/6 are all equivalent fractions, and you can see that because I put this nice little equal sign in between all of them. Next thing we're going to talk about is how to find an equivalent fraction. There's 2 ways to find an equivalent fraction. You can either divide the numerator and the denominator by the same number, or you can multiply them by the same number. Go one way or the other. In this case, 1/3 is in its lowest form. We can't divide 1/3 anymore. It's as low as it can go. So if I want to find an equivalent fraction of 1/3, say I wanted to multiply the top by 4 and the bottom by 4. Well, then essentially what I would get is 1 times 4 over 3 times 4. 1 times 4 is 4. 3 times 4 is 12. So we can say that 4/12 is an equivalent fraction to 1/3. They both represent the same amount. If I have the fraction 12 over 36, I could multiply them to find an equivalent fraction, but if I look at the numbers 12 and 36, I can easily tell that 12 and 36 are from the same family. For example, I can divide 36 by 12. If I divide 36 by 12, that gives me 3. I can also divide 12 by 12, which will give me 1. So I can say that 1/3 is equivalent to 12 over 36. Whether I cut my pizza into 36 pieces and have 12 of them, or I cut my pizza into 3 pieces and have 1 of them, still having the same amount of pizza. These are equivalent fractions. They represent the same amount. The next one I have is 3/8. 3/8. Well, if I look at the 3, right away I think prime number. When I see prime number, that tells me that I can actually divide no more. So in order to find an equivalent for 3/8, I'm going to have to do some multiplying. And it doesn't really matter what you multiply by, as long as you multiply both the numerator, that's the top number here, and the denominator by the same number, you're going to get an equivalent fraction. So for example, say I just want to multiply them by 6. So I'm going to take 3/8, and I'm going to multiply the top by 6, and I'm going to multiply the bottom by 6. 3 times 6 gives me 18. 8 times 6 gives me, what is 8 times 6? I should know this right away. 6 times 8, 48. So I can say that 3/8 and 18/48 are equivalent fractions. We're going to talk about comparing fractions. Now, it's really easy to compare fractions when the denominators are the same. So, for example, comparing 4/6 and 1/6, you're probably thinking, wow, this is so easy. I know that 4/6 is definitely more than 1/6. Because if I look at the denominators, they're the same. So essentially, what we've had is we've had 2 chocolate bars cut into 6 pieces. That's 1, 2, 3, 4, 5, 6. Yeah, we're good. And we're trying to compare which one's more. So the first one represents 4/6. The second one represents 1/6. Easy peasy. 4/6 is greater than 1/6. What about if the denominators are not the same? Well, then we have to find the lowest common multiple. And you learned about lowest common multiple in the last chapter, how to find the lowest common multiple. Now, the numbers that we want to find the lowest common multiple here between 5, 6, and 3/4 are the denominators. Because the best way to be able to compare two fractions is to have the denominators the same. Well, how do we figure out the lowest common multiple of 6 and 4? Well, you could just quickly multiply 6 times 4 and say, well, that's 24, and I'm just going to use that, and I'm going to have both of them be 24. But there is a different way to do it, and that's by making our factor tree. So if we take 6 and we break it down into prime numbers, 6 is 2 times 3. And if I have 4, I break that down and I have 2 times 2. Now, the way that we can find the lowest common multiple, remember, is to take the most ofs. So I would say that 6 equals 2 times 3, and 4 equals 2 times 2. How are we going to find the lowest common multiple? Well, I notice that 6 has 1 2, 4 has 2 2s. We're going to take the most 2s, 2 times 2, to find the lowest common multiple. And then 6 has a 3, and it only has one of them, so we're going to do 2 times 2 times 3. And that's going to give us the lowest common multiple between 6 and 4. If I take 2 times 2, that gives me 4. 4 times 3 gives me 12. So now I know that the lowest common multiple of 6 and 4 equals 12. The next thing I think in my head is, what do I have to multiply the 6 by in 5/6 to get to 12? Well, one way that you can figure it out is do 12 divided by 6. And you know that gives us 2. So I know that I have to multiply the 6 by by 2 to get us 12. We just learned about equivalent fractions. If I'm going to make an equivalent fraction of 5 6, and I've just multiplied the denominator by 2, that tells me that I also have to multiply the numerator by 2 in order to get an equivalent fraction. So I'm going to do that. I'm going to multiply the 5 times 2, and that gives me 10 twelfths. Now, what do you have to multiply 4 by in order to get to 12? Well, I can go down here and I can take 12 and I can divide by 4. And I know that 4 goes into 12 3 times. So 3 times 4 equals 12. Done. So if I have to multiply the denominator by 3 in order to get to 12, then I know that I also have to multiply the numerator by 3 so that I can have an equivalent fraction. 3 times 3 is 9. So now I can go ahead and compare these two fractions because I look at it and I see now, well, that marker didn't work. I see now that both my denominators are the same. I've made equivalent fractions out of the two of them so that I can have exactly the same denominator. So if I look at the numerators now, I can see I have a 10 on the top and a 9 on the top. It's no brainer here. At this point, we know that 10 is greater than 9. So therefore, if 10 twelfths is greater than 9 twelfths, therefore 5 6 is greater than 3 fourths. Another way to compare fractions is to do cross multiplication. So we'll do this one two ways. We'll do this one using lowest common multiple, and we'll try cross multiplication and see if we come up with the same answer. Now, when I do cross multiplication, the thing that you need to remember is that the numerators are going to stay on the same side. So what I'm saying is there's a 7 on this side. We are going to keep the 7 on this side of our comparison. We have an 8 on this side. We're going to keep the 8 on this side. Make sure that the numerators stay on the same side when you're doing cross multiplication. When you're doing cross multiplication, what you're going to do is take the denominator and multiply it by the numerator on the opposite side. I have 13 under the 8, so what I'm going to do is I'm going to take that 13, again, move it on this side. Make sure you don't mix up the side that the numerators are on. And I'm going to do 7 times 13. Then I'm going to take this denominator, the 12, and I'm going to bring it over to this side, and I'm going to multiply it by 8. So then I'm going to have 12 times 8. 13 times 7, I'm just going to go over here, quickly multiply that. 7 times 3 gives me 21, carry the 2. 7 times 1 gives me 7, add 2, I have 91. So I have 91 on this side. Well, what do I have on this side? 12 times 8. Let's do that quickly for a minute. I've got 12 times 8. 8 times 2 gives me 6. 18, carry the 1. 8 times 1 gives me 8. Add 1 gives me 96. Now I can easily compare the two. I'm just looking at that. I know that 96 is greater than 91. So now I can look at 7 over 12, and I had 8 over 13. Because I had 96 on that side, that tells me that 8 over 13 is greater, is a bigger amount than 7 over 12. So I'm just going to write my comparison that way. Now, what if we wanted to compare these two numbers? What if we wanted to take 7/12 and 8/13, and we wanted to compare them using what we know about lowest common multiple? I mean, you can sit there and you can go 13 equals 13, and then write out the multiples of 13, 13, 26, 39, and so on and so on. And you can take 12 and you can write out the multiples of 12. You've got 12, 24, 36, so on and so on. And hope that at some point you find a multiple that matches. Or you can do what our little trick and turn these numbers, the 12 and the 13, into prime numbers. So I'll take 12, make my little factor tree, and I know that's 2 times 6. Bring the 2 down, and I've got 2 times 3. So I can rewrite 12 is 2 squared times 3. Take the number 13. Well, 13 doesn't really divide into anything. It's just 1 and 13. That's kind of it. So I'll take 13, write it here as 1 times 13. So remember, we're going to take the most amount of each thing. So I have here 2 squared times 3 times 13. So the lowest common multiple essentially is going to be 12 times 13. That's as low as we can go. So what is 12 times 13? Well, I know 12 times 12 equals 144. And if I add one more 12, that gives me 156. So 12 times 13 has to equal 156. So I'm going to have on the bottom here 156 on this side, and I'm going to have 156 on that side. Oh, you can't see that. There we go. So to make an equivalent fraction, I have to think to myself, what did I multiply the 12 by in order to get to 156? And we know that that's 13. So therefore, I have to multiply the top by 13. 13 times 7 gives me, well, 7 times 3 is 21. Carry the 2. 7 times 1 is 7. Add 2 is 91. Well, I know that's 91. And we know that 8 times 13 is 96 because we just did that previously. Now we have our denominators are the same. And if I look at the numerators, I still think 96 over 156 is bigger. So therefore, 8 over 13 is bigger than 7 over 12. It's probably not the best example in the book. That's okay. It's the one we've got. A third way to compare fractions is by using a number line. I have here a list of numbers, rational numbers, that we'd like to put in order from least to greatest or greatest to least. So one way that we can do that is by drawing a number line. If I look at the numbers, I have negative 2 1/4, 2 2/3, 1 1/2, and negative 3/4. The smallest number I have is negative 2 1/4. So I'm going to make my number line here. And I've got negative integers and I've got positive integers. So about halfway, I'm just going to do a 0. Now, the lowest number that I need actually is negative 3 because negative 2 1/4 just fits just inside that. The largest number that I'm going to use is 3 because 2 2/3 is just below 3. I'm going to go ahead and plot the other numbers. Right about here, I'm going to do a 1, and approximately here, I'm going to do a 2. Right over here, I'm going to do a negative 1, and right over here, I'm going to do a negative 2. And then over here, I have negative 3. I'm going to go ahead and plot my halves, my half points. So this is about a half. This is about 1 1/2 and 2 1/2. And here I have negative half, negative 1 1/2, and negative 2 1/2. So where would negative 2 1/4 fit? Or negative 2 1/4 fit? Well, we know that's going to be on the other, it's going to be on the left side of the 0 because it's a negative integer. So it's going to be more than 2 because it's 2 and it's negative 2 1/4. So it's going to be roughly about here because 2 1/4, well, the 1/4 is sort of between the half and the 2. So I'm going to go ahead and put that over here, and this is negative 2 1/4. The next number I have is 2 2/3. That goes on the other side, the right side of the 0 because it is a positive integer. So we have 2, and I see 2 is over here, and 2/3. Well, I know that, well, if I look at 2/3, it's a bit of a tough one. What would half of 3 be? So half would be like 1.5 over 3. That would kind of be half here. So 2/3 is going to be just a little bit more than that. I can mentally think in my head that I'm dividing this into 3. I'm going to go over here and I'm going to put 2 2/3 here. The next one I have is 1 1/2. Well, that's easy. I've got 1 1/2. So here we go. This is our 1 1/2 spot. And then the last spot we have is negative 3/4. So negative 3/4 is between 0 and negative 1. And it's about 3/4. Well, this is negative 1/2. So negative 3/4 is going to be in between that. So here we go. We've got negative 3/4. So if I wanted to write these in order from least to greatest or greatest to least, I could do that quite simply. I could say that negative 2 1/4 is less than negative 3/4, which is less than 1 1/2, which is less than 2 2/3. Should make that 2 a little bit bigger. It's 2 whole. So that is 5.2 in a nutshell. You can go ahead and do the assignment that I assigned for you. If you have any questions, please let me know. Thanks.